Okay, we're going to talk some more about the Hindu Arabic system, which is what we're again familiar with, and this is section 4.3 in your book. And we're going to look at how to expand out the number, which is something you probably are familiar with, but maybe in a different way we're going to look at it. And then we're going to look at some historical calculation devices, some of the tools that they used before calculators. So when we're writing out the expanded form, we have to keep in mind what base we're dealing with, whether it's base 10, base 60, base 20, and we have to consider what position the number is in that system. So when we have this number, 23,671, we know that the 1 is in the 1's position, which is 10 to the 0 power. The 7 is in the 10's position, which is 10 to the 1st power. The 6 is in the 10 to the 2nd power, which is 100. The 3 is in the 10 to the 3rd power, which is 1,000. And the 2 is in the 10 to the 4th power, which is the 10,000 position. And then what we do is we rewrite the number with that number system considered, and we end up with, let's see if I can get this to advance. Okay, there we go. We end up with 2 times 10 to the 4th power plus 3 times 10 to the 3rd power plus 6 times 10 to the 2nd power plus 7 times 10 to the 1st. And what you're familiar with probably thinking is you have 2 times 10,000, which is 10 to the 4th. You have 3 times 1,000. You have 6 times 100. You have 7 times 10, and you have 1 times 10, 1 times 1. So this is the ones, tens, hundreds, thousands, 10,000s place in just a little bit different format. So for all real numbers A, B, and C, B times A plus C times A equals B plus C times A. And what we're doing here is the distributive property, or the factoring, if you want to think of it that way. I have A in both parts, so I take the A out, and I'm left with B plus C. So this is one of the basic factorings, also called the distributive property. Okay, so for example, if I have 3 times 10 to the 4th power plus 2 times 10 to the 4th power, I have 10 to the 4th in both pieces. So I can factor the 10 to the 4th out, and I'm left with the 3 plus 4, which is 5 times 10 to the 4th. So again, we're just using some of our basic properties, in this case the distributive property, to do our calculations, as opposed to having to necessarily pull out a calculator and do all of our calculations that way. So what if I wanted to add the numbers 34 and 45 using this expanded number system notation? So that means that 3 is 3 times 10 to the 1st power, and 4 is 4 times 10 to the 0 power, and 45 is 4 times 10 to the 1st power, and 5 times 10 to the 0 power. So this equals 34, and this equals 45. So if I want to add these two numbers together, what I can do is, again, think in terms of I have this in common, so I have 3 plus 4 times 10 to the 1st power. And on the second number here, I have the 10 to the 0's in common, so I have 4 plus 5 times, oops, I forgot my parentheses here, times 10 to the 0 power. And so then I can do my mathematics, and I end up with 7 times 10 to the 1st plus 9 times 10 to the 0. So I would end up with 70 plus 9, which is 79. And of course, you can do this by doing your typical mathematics that you're familiar with, but this is how you would do it using the expanded system. And that's what this is just explaining to you again. So our system is a base 10 system, so we refer to it as the decimal number system. And again, deci comes from the Latin word for 10, but we refer to it as the decimal number system, which is also the Hindu Arabic number system. So one of the most famous calculating devices, other than a calculator, is an abacus, and that's used in many of the Chinese cultures. So on the next slide, you'll see an abacus. And what you have to do when you're reading the abacus is you have to read it from right to left. And it is a base 10 system, so you have your ones place, your tens place, your hundreds place, and your thousands place. And you really need to focus your attention on this area here around the bar, because those are telling you which numbers are active or which beads are active if they're moved towards the bar. If they have, if you want to think of it this way, passed over the bar, then that means they have 5 times that value. If they have not passed over the bar, then they have 1 time. So everything above the bar is 5 times its place value. So 5 times 1, or 5 times 10, or 5 times 100. Anything below the place value is just one single value, whatever place value it happens to be. So whatever the place value is times the number of beads. Okay, so if we look at this example that we have here, we have 1 bead here in the ones place, and it has passed over the bar, so this is considered to be a 5. We have 1 bead here that is below the bar in the ones place, so it has a 1 value. There are no beads here at the bar, so that means that there are no numbers in the tens place. We have 1 bead here that's in the hundreds place, but it's passed over the bar, so it's worth 500. These 2 beads have not passed over the bar, they're on the hundreds bar, so they're worth 100 each, so that's 200. We have no beads here above the bar, so we don't have anything in the 5 times, but we have 1 bead here on the 1,000 bar, but it's below the bar. So we have 1,000, we have 500, we have 200, we have 5, and we have 1. So if we put all of those values together, we end up with 1,000, 500, 200, 5, and 1, which is 1,706. Now you just have to look again at the examples that they give you, but again, what I'm going to tell you to do is focus your attention on this bar here in the middle, and you only want to look at the things that are close to the bar or have been moved towards the bar. So when you're looking at the examples in the book, make sure that you follow that example. Another method that's pretty common is what we call a lattice method. And I know my child came home and they were using the lattice method to teach them multiplication now. So if you do have children, you might be seeing this coming up. So what they do with the lattice method is they set up everything on a diagonal and they multiply things together. So if we want to find the product of 38 and 794 using the lattice method, what you're going to do is you're going to set your 2 numbers up. And since it's a 2-digit number by a 3-digit number, we're going to set up a 3-column by 2-row. And then what you're going to do is you're going to multiply these numbers together on the lattice. So we're going to say 4 times 3 is 12. So we put the 1 here and the 2 here. 4 times 8 is 32. So we put the 3 here and the 2 here. And then we're going to do again, we're going to say 9 times 3 is 27, so we're going to put the 2 here and the 7 here. And 9 times 8 is 72, so we're going to put the 7 here and the 2 here. One more time, we're going to do 7 times 3, so we're going to get 21. And then we're going to do 7 times 8, which is 56. And now for this next part, what you have to do is you have to look at the diagonals when you're multiplying this next part. So let me get my highlighter. Here's one of our diagonals. Here's our other diagonal. So we want to look at the numbers on these diagonals, and we're going to be adding these numbers together. And just like with regular mathematics, you might have to carry. So when I add 2, there's nothing to add to it, so I get 2. 2 plus 2 plus 3 is 7. So we put the 7 below it on the diagonal. 1 plus 7 plus 7 plus 6 is 21. So we get our 1 here, and we carry the 2 over to the next diagonal. So 2 plus 1 plus 5 plus 2 is 10. So we write down our 1 and carry our, we write down our 0 and carry our 1, and then 2 plus 1 is 3. So our answer is 3, 0, 1, 7, and 2. And so when we multiplied 38 times 794, we end up with 30,172. So our last example is what we call a nines complement method. And I wrote down 5 steps. The book actually lists 4 steps because it combines 3 and 4 together. But what we're going to do with the nines complement step is that we're going to align the digits. So in other words, just like we do with subtraction, you line up your ones place, your tens place, your hundreds place. Then we're going to add any leading zeros. So any numbers that don't have a match with it, we're going to add a 0 on. We're going to replace each digit in the subtrahend with its nines complement. And a nines complement is when you just take the number and you subtract it from 9. Then we're going to add the 2 numbers together. We're going to add the 2 numbers together, and then we're going to always delete the leading one and add that 1 to the sum. So I know it sounds like a few steps, but let's look at these steps. All right, so we have the number 2,803. And we want to subtract 647. So step 1, we said, was to set up the numbers and align them. So here's step 1. We lined up the numbers so that the 3 and the 7 are lined up with each other, the 0 and the 4, the 8 and the 6, just like you're subtracting. Step 2 said, add the leading zeros. So we added a 0 in front of the 6, just so that both of them are 4-digit numbers. The next step is where it's a little bit different. So we're going to take each of these numbers on the subtrahend and we're going to subtract it from 9. So 9 minus 0 is 9. 9 minus 6 is 3. 9 minus 4 is 5. Get more of the 3 if I can. And then 9 minus 7 is 2. So then we replace the 0,647 with 9,352. And then we add. So 3 plus 2 is 5, 0 plus 5 is 5, 8 plus 3 is 11, carry our 1, 9 plus 2 is 12, 9 plus 2 plus the 1 is 12. Then we remove this 1, and we basically, if you want to think of it, add it to the end, so you get 2,156. And that's your answer. And that's called the nines complement method. All right. So I hope this is helping. Keep in touch with me. Keep letting me know if you're having any problems. Don't forget to email me or call me if you're continuing to have any problems with anything. Have a great week.